Hey everyone, let's jump straight into this explainer. Today, we are looking at something incredibly special, my handcrafted class notes from episode 01 of NN Sir's mathematics course. We've beautifully upgraded the content here, using a high-contrast dark color on a crisp white background, which, by the way, is absolutely perfect for print production and makes everything super clear. But beyond just looking good, this explainer is about stripping mathematics down to its most elegant foundational truths. It's not just about getting the right answer, it's about actually seeing the underlying beauty of the numbers. And that brings us to this profound philosophy that anchors our entire journey today. Anand Sir deeply believes that children, and honestly all of us, learn mathematics from the heart. What does that actually mean? Well, it means complex math isn't about blind memorization or rigid, scary formulas. It's about developing a really intuitive, deeply visual understanding of how numbers interact. Because when you learn it from the heart, you literally never forget it. So, here is our roadmap for building that intuition today. We'll start with the power of basics, visualize some mathematical laws, prove the negative rules, unlock integer equations, and wrap up with some advanced problem solving. Let's get right into it. Section 1, the power of basics. These are our foundational truths. Okay, we're starting with natural numbers first, denoted by the letter n. You already know these. They're your standard counting numbers, 1, 2, 3, and so on. But what's actually really interesting here is the explicit reminder that there is no largest natural number. You just take any number, n, add 1, and the progression continues infinitely. It's super simple for sure, but it is the absolute heartbeat of all counting. Expanding our mathematical universe just a bit, we introduce integers, represented by z. This group includes our whole numbers, plus all their negative counterparts. Anand's notes explicitly point out that a number like -3 belongs to this set of integers, z. We're just laying the groundwork right now, making sure every foundational piece is securely in place before we build on it. Section 2, visualizing mathematical laws, turning the abstract into reality. Before we get to the real magic, we gotta quickly establish a couple basic properties of addition and multiplication. The commutative law simply tells us order doesn't matter, so A plus B is exactly the same as B plus A. And the associative law tells us grouping doesn't matter. Now, you've probably memorized these in school, right? But we need to see them differently today. Now, this is what learning from the heart actually looks like. Instead of just writing out a dry formula, Anand Sir physically draws out adjacent rectangles to visually prove the distributive law. He creates a physical space. Think about it. The first rectangle has an area of A times B. The second is A times C. Let's compare the two approaches. On the algebraic side, you have the abstract formula. A times the quantity B plus C equals AB plus AC. But on the geometric side, the reality is that the total area of the combined rectangle is exactly equal to area 1 plus area 2. By mapping the abstract equation directly to a simple physical space, the math becomes instantly intuitive. You don't have to memorize a thing, you just see it. Section 3, proving the negative rules. Let's tackle that whole negative times negative rule. So why exactly does a negative times a negative equal a positive? Well, let's use our basic rules to prove it. Start with -a times 0 equals 0. That's universally true. Now, let's just substitute that 0 with b minus b. Use that distributive law we just visualized. We get -ab plus the product of -a and -b. So the absolutely crucial point is right here. By systematically distributing terms and balancing the equation to equal 0, Anand Sir rigorously proves why a negative times a negative must equal a positive ab. It's just pure logic. Section 4. Unlocking integer equations. It's time to dismantle some algebra. Take a look at this question. Solve the equation xy equals x plus y, where x and y are integers. If you just stare at it, it seems kind of impossible, right? How would you intuitively solve this equation using only those basic foundational rules we just set up? Well, going straight to the master's scratchpad, we see this elegant manipulation of variables. These beautifully handwritten notes reveal a really clever, structured approach that turns a confusing jumble of letters into a super clean, solvable problem. Here is the brilliant trick. First, rearrange everything to one side. xy minus x minus y equals 0. Now add 1 to both sides. Why? Because by adding that 1, we can suddenly factor the equation into two perfect integer blocks. X minus 1 multiplied by y minus 1 equals 1. We quite literally just use the distributive property in reverse. From there, mapping out the cases in a simple table reveals our integer solutions so clearly. Since the only way two integers can multiply to 1 is if they are both 1 or both -1, we just set x minus 1 equal to 1 and y minus 1 equal to 1. The result? X equals 2 and y equals 2. It's simple, clean, and totally undeniable. Let's level up slightly and see how this builds on a harder equation. xy minus x plus y equals 3. We apply the exact same logic. This time, subtracting 1 from both sides achieves that beautiful factorization. We group the terms to get y minus 1, multiplied by x plus 1, equals 2. Now you just find the integer factors of 2. It is basically like unlocking a puzzle box with a master key. Section 5, Advanced Problem Solving. We are scaling the basics way up now. When you look at these incredibly detailed handwritten notes, I know the problems look totally intimidating at first glance. There are more variables, higher numbers, and way more complex constraints. But do not let it overwhelm you. The heartbeat of the math remains completely identical to what we've just practiced. For instance, take this one. xy plus 1 equals x plus y. We just do the exact same dance. Rearrange and factor, getting x minus 1 times y minus 1 equals 0. And here is where it gets really fun. Because the product is 0, we instantly uncover that setting either x to 1 or y to 1 unlocks infinite integer solutions for the other variable. Now look at 5xy plus 3z equals 14. This one has a special rule attached. We are restricted strictly to natural numbers. Remember those from the beginning? Just 1, 2, 3, and so on? Because of this constraint, we just logically test values for z. If z is 2, 5xy equals 8, which doesn't work for natural numbers at all. But if z is 3, 3 times 3 is 9, leaving 5xy equals 5. The equation elegantly balances out to xy equals 1. So x must be 1 and y must be 1. We've seen how Anonsur uses geometry to prove algebra, logic to prove negatives, and clever factorization to solve integer equations. Before we wrap up this explainer, I'm going to leave you with this final puzzle directly from episode 1 to test how well you've learned to see math from the heart. How would you solve x squared plus y squared plus xy times the quantity x plus y plus 2 equals 6? Grab a pen, maybe some dark ink and a white piece of paper, and see if you can find the elegant truth hidden inside.